Hi, I'm Gretchen. Today I'm going to explain how to speed up the performance via a special technique called cache. Although main memory seems to be fast, however, cache do much better job is because it is closer to CPU. There are several schemes on the mapping, but today we are just talking on direct mapping technique. While main memory are accessed by the address, cache were accessed by block, which also means we need to copy a bulk of the data by once. And you see, because there are two blocks of memory, points to one block of cache, which means there are two blocks on the main memory shares the same space on cache. So we need to define another way to access cache, like shown before. Take a look on the field of the newly assigned main memory address. The addresses are partitioned into tags, blocks, and offset. The offset field identifies an address within a specific block, and the block field selects the unique block of cache, and the tag is what is left. With this let's take a look on an example. Consider a specialized main memory which consists of 4 blocks and cache with 2 blocks, and where each block is 4 bytes. With this information, we can conclude that the offset of block is 2 bits because we need 2 lines to address 4 positions. And we also need 1 line to control which blocks in the cache was selected. And finally, because memory was consist of 4 blocks, which need 2 to 4th power, and this means 4 lines to address. So we can get tag line is 4 minus 2 minus 1 equal 1. So we need 1 line for tag, assuring we are selecting the right data. Now we can see how do CPU access data. Suppose we want to access the address 3, hexadecimal 3. We first separate the 3 into binary, and then we can decide the offset, blocks, and tags. The thing was sent for address A. Now you see the block 0 and block 1 are for tag 0, and the block 2 and block 3 are for tag 1. So for 0011, we select the block 0 and offset 11, which means this position, the first position of the block 0. After we dive in to the data accessing, there's another important field called valid. This flag determines if the region was written before. Based on this figure, we know if the machine was in initial state, the valid tag will be 0, which means there's no data in the cache. So we just access them in the main memory and store them in the cache for later usage. With this concept, we define another flag called hit, which means if we get the right data. You see on the example, we have 2 blocks in the cache and 4 blocks in the memory. How can we assure that we get the right block and right data? So the tag was sent, if the tag was sent and the value was high, this means we can get the right data. Otherwise, we read data from a memory and we overwrite the block.